Okay, so here we go. Example 6, usual routine. Let's go through and pick out the key information in the question. So a mass is 8 kilograms. It's limiting equilibrium, so it's on the point of slipping, on a rough plane, 20 degrees above the horizontal. Find the coefficient of friction between the box and the plane. Okay, so just pause it. Have a go, try and sketch the diagram, put on all the forces, and then have a look at what follows. So it's a horizontal plane, so inclined at 20 degrees. We've got our particle, we've got 10g acting downwards, 10g acting downwards, let's just tidy that up. So 10g acting downwards. We've got our normal reaction to the plane. The box is trying to slide down the plane, so the friction is going to be acting up the plane and parallel to the plane. And mu is what we've been asked to find. So, as usual, we're going to have to work parallel and perpendicular to the plane. And if we need to do that, we need to break the weight down into its components. So we've got a component here, which is perpendicular to the plane. That angle in there will be 20 degrees. This is next to the angle, so this is 10g cos of 20. This is perpendicular to the plane here, so this will be 10g opposite the angle, so it's sine of 20. Okay, so let's begin. If in any doubt, we know what we're going to have to do. We're going to have to work parallel to the plane. Doesn't matter which we take as positive, but I'm going to go up, resolve, parallel to the plane and up the plane. We get the friction minus 10g sine of 20 equals 0 since equilibrium. Right? So there we've looked at those parallel to the plane. We've got that component there gives us that line. Okay, now we resolve perpendicular to the plane. So here, go back to the diagram, we've got that vertically or perpendicular to the plane, that perpendicular to the plane. So we're going to get r minus 10g cos of 20 equals 0 since in equilibrium. So the green gave us that equation. We're looking for mu, so we've got to have friction in there. So we know that on point of slipping, or in limiting equilibrium, we're going to have friction is equal to mu r. So we can substitute in for the friction from above, and we can substitute in for the normal reaction from above. So friction is 10g sine of 20 equals mu r, which is 10g cos of 20. So mu is equal to, divide by 10g, sine of 20 over cos of 20, and we should know what that is. We should be able to recognise that as tan of 20 degrees. You can type it in a calculator. It should come out to be, I don't know, about 0.3, 0.4. Just check that. I don't know, approximately 0.4, but you can tap it in the calculator to check. I think that, yeah, I'm just doing it, that equals 0.36. Okay, so it's actually 0.36 to 2dp. Okay, go back. Have we answered all the question? No. All right, so a horizontal force of magnitude P is applied to the box. Given that the box remains in equilibrium, find the maximum possible value of P. Okay, so part B. We've got the same plane, the same angle degrees, we've got the same mass of 10g. Pause it there. You can try now and add the rest of the forces onto that diagram. Okay, have a go and then carry on playing the clip. So let's think. We've got a reaction here, R. Now the key phrase in this question is find the maximum possible value of P. So P, if it's about to slip, which direction? Hang on, we're told the direction of P. P is applied to the box, given the box a horizontal force, yeah? So horizontal force, P, is applied to the box. That's got to be here, horizontally, P. And that means it's at its maximum, max when box tries to slide up the plane. So what can you tell me about the friction? Yeah, therefore friction acts down the plane, right? And that's the key thinking at the start of the question. If we don't get that right, everything else isn't going to work. So the friction must be acting down the plane. All right, what else do we need to do? We need to break these down because we know we're going to be working parallel and perpendicular to the plane. So we need the components in those directions. So perpendicular to the plane here, we've got 20 degrees. So this is going to be 10g adjacent to the angle cos of 20. Here, opposite, we've got 10g opposite the angle sine of 20. If we come up to here, if this is 20 here, this is corresponding, so this is also 20, and this one then is adjacent to the angle next to it, so this will be P is its magnitude, adjacent to the angle, so cos of 20 degrees. Here we're opposite the angle, so it's going to be sine, so this is P opposite the angle, sine of 20. So we've done the preliminary work on the diagram, and now we can do our usual routines. Resolve. Parallel to the plane, I've taken up as positive, you don't have to. Let's pick out the forces that are parallel. So we've got one there, one there, one there. Can you see any more? I can't, that's the lot, I think. So we've got P cos of 20 minus the friction minus 10g sine of 20 equals 0. Okay, now we can look perpendicular to the plane. Resolve. Perpendicular to the plane. And we get what have we got? Perpendicular to the plane. So we need to look up here. What have we got perpendicular to the plane? We've got R, we've got 10g cos 20, and we've got this p sine 20 over here. So we've picked out those components. So we've got R minus 10g cos of 20 minus p sine of 20 equals 0. These are both since equilibrium. So here, friction. We've got the usual situation where we've got looks like three unknowns again, yeah? P, friction, R, P. What have we been asked to find? Okay, so find the maximum possible height. We know mu this time because we've worked it out earlier. Yeah, mu equals tan 20. Right, so from above, because the slope hasn't changed, yeah, we're on the same slope here. Mu is equal to tan of 20. It's the same slope. Yeah, same plane, therefore mu still equals tan of 20. So we're going to be able to use friction, so on point of slipping, we can use our friction is equal to mu r. Okay, so mu we know is tan of 20. We can substitute in for that, tan of 20. R. Well, where's R going to come from? R can come from here, can't it? Yeah. So let's rearrange this. R is equal to 10g cos of 20 plus p sine of 20. So this is 10g cos of 20 plus p sine of 20. Don't forget the brackets because it's all multiplied by mu. Friction we're going to be able to take from here somewhere. Yeah, so friction, yeah, we're going to be able to take from this equation, so we can work out friction. Friction, adding friction across, is equal to p cos of 20 plus, no, not plus, minus 10g sine of 20. And we can substitute that down here. So for friction, we will then have friction is p cos of 20 minus 10g sine of 20. Okay, now just like the last time, we need all the terms of P on one side and everything else onto the other. So we can expand this, P sine 20 tan 20 plus 10g cos 20 tan 20. Collect the terms of P in, so we get P cos 20 plus P sine 20 tan 20 is equal to 10g sine of 20 plus 10g cos of 20 tan of 20. Well, tan is sine over cos. Yeah, we know this is sine 20 over cos of 20. So these, in effect, cancel. So we get 10g sine 20 plus 10g sine 20, which is a total of 20g sine 20. And here we've got p cos 20 plus sine 20 tan of 20. So p equals 20g sine of 20 over cos of 20 plus sine 20 tan of 20. And then that's going to require a little bit of tapping in the calculator, isn't it? I'm not easy to get that anywhere close in my head, but it should come out to be 82 newtons to 2 SF. Okay, homework then attached with that piece of work will be page 139, exercise 7C, and that'll be questions 8, 9, 11, 12, 13. If you find those a bit tricky and you're not getting the answers right when you first start, then go back and try some of the easier questions near the beginning of the exercise instead, and then perhaps come back to these later on when we've done a little bit more practice of starter activities. Okay, hope that helps, and good luck, guys.